And
oh, just like.
Oh, sorry.
Yeah, it's like.
So we're at the Wikimedia Foundation here, and we're doing the research showcase. I'm Abby Ribstra, the lead design researcher here at the foundation, and we have two speakers today, each of which will have 25 minutes for presenting, and then there'll be 5 minutes after each presentation for questions. And then at the end, after people can stick around after the hangout is closed, we can continue our conversation on IRC. Guillaume is going to be monitoring IRC for questions, and that's the situation. So welcome. Thanks everybody for coming. So we have two speakers, Giovanni Ciampaglia, and he's a research scientist at Indiana University, and he'll be talking about computational fact-checking from knowledge networks. And our second speaker is Aaron Halfaker, our principal research scientist, and he will be talking about deploying and maintaining AI in socio-technical systems, lessons learned. So with that, I think we can get started with Giovanni. So I'll pass it over to you.
Great, thanks Abby for the introduction. Thanks for inviting me. It's always a pleasure to come here and hang out virtually too, actually. So today I'm gonna talk. Well, my name is Giovanni Ciampaglia. I'm at Indiana University at the Network Science Institute, and today I'm gonna talk about computational fact-checking from knowledge networks. This is a project that I've been involved for some time now, and I'll just go into some motivation. We nowadays we know there's quite a lot of misinformation going on the internet. For example, I hope people can see the mouse. Okay.
Where's the mouse?
Oh no, that's fine.
Oh.
I can see the mouse.
Okay, perfect.
Okay.
So usually, I think things like chemtrails and other conspiracy theories are nowadays quite famous, and people have heard of them. But and here I've assembled a few pictures from classic conspiracy theories. An interesting thing as I was going through the internet, finding these pictures, is that the rumor mongering and in general what now we call conspiracy theories or misinformation have been with us for quite a long time, actually. When people when the Pearl Harbor attack, for example, occurred, stories went around saying that it was a kind of inside job, or that the federal government knew about it, and of course then we all know that Elvis is still alive, or that the landing on the moon is fake. So this is kind of like an example of the rumor behavior or misinformation that is kind of like mushrooming, or a grassroots from the bottom up. On the other hand, we know also that in public discourse and in politics as well, it's quite well documented that there's a lot of inaccurate statements. Journalists, pretty much that's their job. There's in fact-checking the statements and the claims that politicians make. For example, here I'm showing to you a few outdated examples from this website called politifact.com that is run by the Tampa Bay Times. It's a Pulitzer-winning project. There's one, I think, has been one of the first modern fact-checking organizations that actually communicates through the internet and collects these snippets, these short statements. I think they are the first that came up with the idea of the truth-o-meter, giving a tongue-in-cheek assessment of the veracity of a statement. And I mean, as you can see, now I guess maybe these are not household names. I think I took these screenshots when few years ago when I didn't really know much about the classical U.S. politicians, but more or less there's people from both sides of the spectrum. So it's not to say that it's a partisan issue. It's totally bipartisan and so on. And that, if you will, is kind of like some kind of top-down as sources, prominent sources like spread claims and so on. We also have this other problem that is increasingly current. A third one that I just added, I think this morning actually, is something I would say a bit in between, and it's what these days are starting to be known as fake news websites. And these are, I think, somebody came with the best description, which is that it's like The Onion but not funny. And the idea is that these are pretty much satirical, or at least they portray themselves as satirical outlets, but they play a lot with like emotions and fear-mongering and so on. So usually this is national record that was for a while quite popular in terms of shares and so on social media. And usually when you scroll down at the bottom of the page of these websites, there's always a little disclaimer in like fine print saying this content is purely satirical and so on, which of course nobody pays attention to, and it has been the case here. For example, in this example, I think is one of their stories that went out during the Ebola scare, completely fabricated, that got a lot of shares. Now, of course, here the incentive is to serve ads, so that's why they're very active on social media. And this is, in a certain sense, almost like a new phenomenon, because there's never been a strong monetary incentive toward like fabricating misinformation. So this is to say that right now, with the internet, with days of communication that we have through digital technologies, there's this rising problem of misinformation. It's growing at a very high pace, and journalists cannot really keep up with it. It's a bit of a problem because, of course, when these things get much more prominence than probably they should do, and they're known to cause, as with the normal, the traditional notion of misinformation or rumor, sometimes they can cause scares, panic, and so on. So one idea is that the antidote to this tradition has been called fact-checking, which is what journalists do. They go through a story or through statements and claims, and they make sure that everything is accurate, that they try to find the original source, they look for nuance, various kinds of spins, and so on. And this has been, by and large, a manual activity. Only really large news organizations like, for example, the New Yorker, the Spiegel, can really afford dedicated departments. So it takes a lot of time, actually, from the basic reporting and so on. And so our question with this work was, is it possible to automate, if not completely, but at least some parts of this effort? So the question is, how do we help journalists? And of course, we're not the first to think about it. In fact, there's a emerging movement of fact checkers that is really taking food. Perhaps many of you know about Snopes.com, which is one of these urban legend trackers. But these days there are like young, small organizations, there news organizations that are completely devoted to fact-checking. An example is Full Fact, which is a UK organization. There's other also outside in the non-English speaking world, like Pagella Politica, which is an Italian one, Checado, which is a major fact-checking organization in Argentina, I think. And of course, also the more like traditional, the more mainstream media outlet have been experimenting with approaches to to help to automation. For example, the Washington Post some time ago tried to come up with a prototype called the Truth Teller. And as I said, there's things like PolitiFact and so on. In addition, now we're starting to see startups that are seeing that perhaps there's also like opportunities for business in delivering or checking inaccurate claims, and of course things like Claimbuster, TreatCred, and so on are research projects like ours. So there's a lot of attention on this problem, of course. So I've painted this picture of the internet as this place where like misinformation travels free without problems. But on the other hand, we all know, especially in this room and for the people watching online, that there are places where accurate information, the production of accurate information. Of course, Wikipedia is an example. I don't have to preach to the choir about the fact that yes, there is vandalism, but the community knows how to deal with it in a very efficient manner. There are an interesting fact is that there are now also more large-scale systems, in particular, that are trying to structure knowledge. So these are called knowledge bases. Examples are Freebase. Now Wikipedia has its own called Wikidata, or DBPedia was a project that even predated it, or Yago, and other commercial and academic projects. And an interesting important detail of this is that all these knowledge bases that collect structured knowledge using ontologies and so on can be also seen as instances of knowledge networks. A quick example here, in this project we used one such knowledge networks using the data from DBPedia, and for audiences that have little knowledge about how Wikipedia works and so on, I always try to explain that there is a difference between taking the whole knowledge that is in a Wikipedia page and only focusing on something a bit more structured, like the information presented in the info boxes. And so in this case, the DBPedia basically scrapes the markup of info boxes on Wikipedia articles, applies some normalizations to the various relations and entities, and produces nice clean dumps in RDF format, which is a classic format for the semantic web. So when you start adding knowledge on a knowledge network, you may start from people, politicians, when you add geography, countries, and so on, and general culture. And what you end up is this idea, like an idea in which of a network in which nodes represent entities, so the topics of pages or articles, and there are relations between entities that are labeled with a semantic meaning. So in this case, for example, the birthplace of Barack Obama is Honolulu, his profession is President of the United States, or for example, if you look at socialism, you will know that the red is the color of socialism, and so on. So these networks, of course, are these days are massive. I think Freebase had something like a billion facts. DBPedia has some order of magnitude less, but still in the millions. And of course, there's all kinds of things, and one can imagine that maybe exploring a network like this, one can find, even if you don't find the direct connection between Obama and socialism, and maybe by starting navigating through these paths, these nodes, one can find a connection. And before but that's another story. But before showing you, to give you an example of what it means, just a quick few more facts about the DBPedia. So it's it should be about, I think we used the dump from 2012 at the time, and it contains about 23 million facts. And this is like this list gives an idea of like the kind of semantic relations that you find. So the top one, which is by far the most common one, is what the RDF word is the instance type relation. Is this entity is an instance of this type. So Barack Obama is a politician, for example. Then you have other relations from other namespaces like friend of a friend, or information about sports, about geography, about biographies, about literary or artistical genres, and so on. So this gives an idea that basically DBPedia covers pretty much the huge variety of knowledge that Wikipedia does. And so in this case, like to give an idea of the definition of the problem is that, say we want to try to we want to find a or like compute the support, the confidence of statements that we don't see directly into Wikipedia, into the database. So the example would be whether Obama is a socialist or is connected to socialism and so on. We want to formalize in terms of like more or less like an inference problem. An hypothetical agent can by exploring this network find support, and how hard it is. In mathematical terms, this amounts to an operation called graph closure. I won't go into much detail, but so to go back to this, this old example of Obama socialism, when you actually do launch a computation for a connecting path, which technically is the shortest path, you do find something like this, that Obama, and here I'm disregarding the actual relation, the semantic relation on these edges, but Obama, I think, appointed Richard Lugar, who was a politician from Indiana, if you don't know, who I think was the mayor of Indianapolis. Indianapolis is the sister city of Monza, which is an Italian city that was ruled by the Democratic Party, whose color is red, which is the main color of socialism. So of course, everyone lost, because this is like a completely nonsensical, or more like a free association path. But when we look at that, we thought, okay, but what does this chain of entities make the statement Obama is a socialist a low confidence statement? Why this is very low, does give a very low support for this statement? And what we thought is that what's going on here is that you have to necessarily go through entities like red or like, I don't know, Indianapolis and so on, that are more general than other entities. So there's a lot of things that are red, or there's a lot of people that live in Indianapolis. And so when your path crosses these entities, more or less it's kind of penalized. It cannot give you much information, so to speak. And this can be formalized mathematically. I won't go into the details, but it amounts to more or less this intuition that for each path can be associated to a notion of how much information it gives you when you select it. And there are formulas, of course, for that. And there are also other alternatives in which you, in the previous case, you're considering both the fact that the entities along this path shouldn't be general, must be more specific, but and also that this chain shouldn't be that long. Whereas you can also focus on the weakest chain in the link, and you get a different definition. And the intuition again is that your inference is as weak as the weakest chain in it. So that's more or less the general intuition for this algorithm. And as I said, it's an exploration on this knowledge network. And of course, after we implemented, we decided to test it. And of course, one one problem is what kind of testing framework to use, because of course this requires to fabricate both true facts but also false facts. And here we're, of course, we're making the very simplifying assumption that everything that was extracted by DBPedia from Wikipedia at this point is true, is prior knowledge. Of course, we do know that at any given time there are a few there are inaccuracies due to vandalism and so on, but we're doing an assumption. So this means that basically all the knowledge we have is true. So we have to fabricate false statements, and the way we do it is to focus only on certain specific domains and to take a kind of somehow a multiple choice approach. So in this example, the idea will be, let's see if the algorithm is able to discriminate between only looking at the more narrow problem of determining who's the spouse of whom. And here we just focused on presidents and their spouses. So it's the algorithm, since of course you can imagine that everything more or less is connected on Wikipedia. You can always find a path between an entity and any other entity. If for example, our algorithm gave the equal support between Michelle Obama and Jacqueline Kennedy for trying to pair it with JFK, then this means that it's not really able to discriminate. And this is kind of a sanity check, basically. Like we're asking, is Paris the capital of France? Well, we know that there are other Parises around the world. We focused on 4 topical domains. We looked at Oscar, directors who won the Oscar for Best Director and the movie for which they were awarded, US states and their capitals, war countries and their capitals, and as I said, US presidents and their spouses. Okay. And of course, in this is what is in machine learning is called a lead prediction problem. So of course, whenever and of course when we run our algorithm, of course, in many cases we know that like there is already a direct edge between, for example, Obama and Barack Obama and Michelle Obama. So of course, this will be kind of like cheating. When we run this test, of course, we remove any direct edges. So this is an example of results, again using the presidents and first ladies. In this matrix, basically, each row is a president, each column is a spouse, and colors are mapped so that the intensity of the color is mapped into the confidence that the algorithm extracted. So the diagonal of this matrix will be only true statements, and everything that is off the diagonal are false ones. And as you can see, the algorithm is able more or less to discriminate between true things and false ones. There is a little bit confusion when, for example, you do end up with spurious relations. A classic example would be George W. Bush and Barbara Bush. Of course, there is a semantic relatedness there, but it's not the actual semantic relation that we were looking for. When you look at similar results for these other datasets, we also get very encouraging good results. You can actually distill all this information in a number, basically, that is called the area under the receiver operating characteristic curve, and it's basically the probability that given a false and a true statement, our algorithm is able to give more weight to the true one. And here we do really well. Of course, this is like information that's very, in a certain sense, dense in the Wikipedia knowledge network graph, and so we were expecting to get good results. We also looked at more peripheral instances of knowledge. We leverage a data set published by Google for that. I won't go much into details in the interest of time. We of course, predictably, we don't do as well. And as you may have imagined, the reason is that, as I said, at this point we're disregarding, when we do this navigation with this exploration on the network, we're disregarding the semantic of the. And so one idea is that we want to reintroduce the semantic, and one approach is to treat. So far we've looked at a single network, but really this knowledge network is the collection of many different networks for each different relation. We're currently working on this approach based on tensor factorization. Again, I won't go much into the details. I just wanted to. We're now also working together with some other collaborators at Indiana University at like an actual demo, something that people can use. We call it knowledge linker because at this point we realized that we've been working so much on it and we didn't have a name for it. And the idea is that you have this kind of simple subject predicate objects. The user can start writing. You get some auto completion. For example, you get Bill Clinton, spouse of Hillary Rodham Clinton, and the algorithm will run and report the result that includes, of course, a number, more like this kind of truth meter, but also, and I think very important, it will also show what kind of path it found. So in this example, it would tell you that Bill and Hillary are married to each other because Bill is the father of Chelsea Clinton, who's the daughter of Hillary Clinton. So that gives you also an explanation. That's something that is more approachable, more understandable for a human user. And with that, I'm done. I would like to thank all the other collaborators and, of course, the funding agencies. Thanks.
Thank you. Does anybody have any questions? Or?
I have a question.
Mm-hmm.
So it seemed like the weighting of the value of a node, right, is kind of about whether it's general knowledge, like how specific it is, right? Yes. So like things that you're an American citizen is basically useless, but that you live on this block in San Francisco is much more specific.
Yes, yes.
That's very similar to like the concept of entropy in machine learning and stuff, right? Yes. Where it's like the information value. And yes. I was just curious if you guys have thought about that scale, like that measurement and how you're doing that measurement.
Yeah, that actually is exactly. So that was the idea, pretty much. And the way we actually measure this generality at this point is looking at how many statements that particular entity is part of, which in terms of a network means to measure the degree of this node.
We have one question from ISC, which is, do you use Wikidata as a source of data?
At this point, not yet. We would really like to also start using Wikidata. The reason why is that when we started Wikidata, I think Wikidata was still very early in its development, and whereas DBPedia was producing these really nice yearly dumps and so on. I have to admit, I haven't really looked at the various. I know that Wikidata has various interesting features that make it really attractive to when you look in particular at like knowledge that's been produced in a collaborative setting or where there's different points of views and so on. And we haven't been thinking yet about how to exploit these additional data.
Any other questions, comments? Okay, thank you very much.
Thanks.
So now we'll go on to our next presenter, Aaron, who's going to talk about deploying and maintaining artificial intelligence in a socio-technical system and the lessons learned.
All right, thanks, Abby. So let me get my screen share going. Okay, so as Abby said, I'm Aaron Halfaker. I'm a principal research scientist at the Wikimedia Foundation. And as I do at the beginning of a lot of the talks that I give at this showcase, I want to highlight a simple statement that I have on my profile page to sort of orient you towards what I'm about to talk about. So this statement is think big, measure what you can, and build better technologies. So this presentation is going to be firmly seated in the build better technologies part of this statement. I see a little bit of concern in San Francisco. Am I doing okay?
Just me. I haven't clicked over to your presentation now, though.
Okay. All right. Well, the only thing that y'all missed was me just putting this thing in front of you so that I could talk about it. Okay. Great. So today I'm going to talk to you about three things. And as you know, if you've seen any of my presentation, I have this thing about three things. So first, I want to talk about the vision of ORS, which is the system that I've been working on for a while, and about how it's intended to bring efficiency and innovation to some processes in Wikipedia. Then I'll talk about how some of the AI within ORS has social dangers, and we actually realize those through the deployment of this system. Then finally, I'll talk about this idea of an intuitive evaluation, or how we ask the humans to help us evaluate our algorithms in order to try and deal with these biases or these potential biases in a robust way. Okay, so let's start off with ORS vision. So what's ORS, you might ask? If you haven't seen my talks before, then you probably have no idea what the heck I'm talking about here. But before I get into that, I actually want to answer a different question. Why is ORS? And so for that, I want to give you a little bit of background. I'm going to go back about 10 years to when I first started looking at Wikipedia as a thing and how I started thinking about what we might need to do in this sort of open knowledge system in order to make it work. So in 2007, this was the start of a period in English Wikipedia and a lot of other large wikis that I commonly refer to as the decline. Suddenly, the population of people that edited Wikipedia stopped growing exponentially and entered this steep and steady decline phase. Around 2009 was the first time that we actually noticed that this thing was happening. And so Bangwan Sa and his collaborator, Kisim, about the slowing growth of Wikipedia, and it turns out that I also had my first publication there where I was looking at how reverts, how control over content would affect people in Wikipedia, and who was targeted for those sort of things. So in 2011, there was an initiative that was started at the Wikimedia Foundation called the Wikimedia Summer of Research. Notably, Giovanni joined me on this research team. There were, I believe, 8 of us. And we sat down for the summer on the 6th floor of the Wikimedia Foundation, and we scienced the bejesus out of this problem, trying to figure out what the heck could possibly be going on, why there was a decline. Like, honestly, I actually tried to get all of the core figures from the studies that we ran onto this plot, and I could not do it. And so I'm going to have a link in a little bit, and I'm going to try and direct you there. But please, if you're interested in this sort of stuff, it's really interesting to go look back at these studies because we really looked at this from a ton of different angles with a ton of different methodologies. So based on what we learned from that summer of research, Jonathan Morgan and a few of his collaborators started an initiative on English Wikipedia for welcoming newcomers called the Tea House. And we worked together along with Stuart Geiger and John Riedel to publish a paper that sort of summarized what we thought were the key takeaways about this, called Rise and Decline of an Open Collaboration System. Essentially what was going on is that Wikipedia's quality control had gotten really good to deal with its scale, but its socialization practices for helping newcomers feel welcome didn't grow in step. So I started doing work on trying to solve this problem, and so one of the first systems that I built in order to make it easier for people to socialize newcomers at scale in Wikipedia was called Snuggle. And arguably, this system wasn't terribly effective at doing its intended goal of actually boosting the number of active editors in Wikipedia, but it did sort of help people think about the potential of solutions that were in this space. And that actually sort of led to some of my follow-up work, trying to understand how exactly the system dynamics of Wikipedia worked, why Snuggle didn't work, and what might actually be able to help this system come together. And so in 2014, I made some presentations about how quality control workflows in Wikipedia come together, such as this example that I have below the timeline of the process for page creation that involves the articles for creation on English Wikipedia. And thinking about Wikipedia as sort of a living system that doesn't have a centralized control mechanism. Instead, it's sort of a complex living thing that has distributed control mechanisms, and this has implications for how we're able to change and what we're able to develop. And so that finally brings me to, it was around the end of 2014 that I started work on this system that I call ORS. I actually presented first on ORS at the end of the summer of 2015. Calling it the People's Classifier Service. And so anyway, so this is sort of the background with which I'm coming to this. Looking at a problem, getting a big sense of what could possibly be the cause of it, trying to address the cause and failing, and then thinking deeper about how systems actually work. Okay, So, and by the way, so this list of references, I actually already have my slides up on the wiki. Of course, you're not going to type these into your browser right now, but if you go and look at my slides on the wiki, then you can click on some of these links. I just want to call your attention to two things. One is the Wikimedia Summer of Research page on Meta is great. It has links to all the studies that we did. It's good to just scan through, if not actually to read through a few of the studies. And then finally, the last link there, which is my presentation on ORS, that will give you a lot more background on how the system works and how I think it might be important for helping Wikipedia and other open knowledge systems balance quality control, newcomer socialization work, and a lot of the other backlogs that are necessary in order to keep these kind of things running. So just to summarize, why is ORS? Wikipedia has socio-technical problems with newbies. Essentially, it's throwing the baby out with the bathwater. Many of these problems are due to scale. Wikipedia is enormous. It's like a fire hose of incoming edits and new editors and new pages, and these all need review, and it's really hard to do in real time. ORS is an attempt to try and address both of these issues at the same time, to both handle with problems of scale and open the conversation about how we should socialize newbies so that more people can get involved in that, so that it's not just computer programmers like me. And to do this in a way that accounts for the fact that Wikipedia is a distributed complex system that's a lot more like a living organism than some, corporation with centralized control. All right, so now getting actually to the question.
Sorry to interrupt. People are saying on IRC that they're not seeing your slides anymore.
Oh, okay. Am I selected in the room?
You are, and
this is an old slide.
This is the YouTube. It seems like the YouTube is very delayed.
But this is not the slide. This is the slide.
Yeah, something's. It seems like the YouTube is very delayed.
But this is not.
Almost
it seems like the YouTube is very delayed.
Uh-oh. Somebody needs to mute that immediately, otherwise it's going to keep happening.
It seems like the YouTube is very delayed.
Somebody needs to mute that immediately, otherwise it's going to keep happening. Okay. So I'm looking at IRC now. Can somebody on IRC tell me if they see me? Because they should see me now and not my slides. So I'm looking at IRC now. Can somebody on IRC tell me if they see me? Because they should see me now and not my slides. So I'm looking at IRC. Okay, great. So maybe we can just keep San Francisco muted, and I can talk, and it looks like if I screen share again, then people can see my slides. So let me try that. Okay. Well, I'm sorry if I lost you guys a little ways back, but I'm just going to highlight a couple things real quick, even though I'm a little bit behind, so I'm going to have to kind of race to keep up. And that's I have this slide with a bunch of references on them. I was directing y'all to the Wikimedia Summer of Research link and the link to my most recent talk about ORS that will give you a lot more background that I just don't have time to do right now. You can find these online. They're on the showcase page. So why is ORS? We're throwing the baby out with the bathwater because we have socio-technical problems. A lot of them have to do with scale. ORS is an attempt to both address efficiency issues at scale and allow greater conversation about how we should socialize newcomers, and an effort to try and do this that accounts for the complex dynamics of Wikipedia. Okay, so moving forward with what is ORS. So in order to talk about what ORS is, I want to talk about what a machine classifier is, because that's really what ORS is at its core. So a machine classifier takes some statistics about a thing. In this case, I have some statistics about an edit that would happen in Wikipedia, whether the editor is anonymous or not, how many characters did they add, how many did they remove, did they make a custom comment, how many characters did they repeat, what's the longest token that they added, did they add any bad words, this sort of stuff. And so the machine learning model will learn how these statistics correlate to some outcome measure, such as, was this edit good or bad? And then we can use it to make predictions. It essentially classifies edits into those edits that are good and those edits that are bad. And so this is really useful. This particular classifier is really useful for counter-vandalism work. It essentially lets us take the fire hose that is 160,000 edits per day for English Wikipedia and split it into the 90% of edits that are probably okay and don't need to review at all, and the 10% of edits that might be vandalism and are probably worth reviewing. So to give you a sense for what this means for real people in their time is that without ORS, without any sort of support, reviewing 160,000 edits per day would take about 267 hours, or 33 people working full-time at 8 hours per day. But with ORS, with this filtering mechanism, we can only review 16,000 edits per day and expect to catch all of the vandalism. And so that reduces this to about 27 hours, or about 4 people working 8 hours per day. And so what I want to instill in you is that this has a massive efficiency benefit using these classifiers with these processes in Wikipedia. But it's not just detecting vandalism that we can do. For example, we can actually use a very similar classifier to the one that I was just talking about to identify which of the 1,500 new editors that we get per day vandals need help or are actually doing just fine. And so there's actually some future work here. I don't have good estimates for the amount of time that are spent socializing newcomers, so I'm not quite sure how this classifier or how much this classifier will make the lives of socializers more efficient. That's something that we ought to look into. But the point is that in this vision of the world, someday ORS will turn the tranquil fire or the fire hose of Wikipedia into tranquil waters, and it'll make everything easier. And we'll all be able to relax and write Wikipedia articles more. And we're getting there. So we have a production level web service at ors.wikimedia.org. You can use this right now. It's designed for tool developers. We already have basic counter-vandalism support in the form of the ORS review tool deployed on 6 wikis. And we have active projects going with the Wikimedia Foundation collaboration team and with tool developers to develop new tools on top of the system. I just have a couple screenshots here. This is the ORS review tool, and here are some mock-ups of the new review interface that the collaboration team is putting together. So beyond just the review tool, we actually making predictions in 20 wikis with 4 different prediction models. We can predict whether it's likely an edit will need to be reverted, whether it was saved in good faith, whether it damages the article, and we can even predict the quality level of an article at the point of a revision. Okay, so point 2. There's some dangers here and some monsters in this tranquil water, at least if we're not careful. And I want to talk about some of those dangers that we actually realized in the process of deploying these machine learning models. So in order to get started in this, I want to channel Zeynep Tufekci for just a moment and talk about what she refers to as subjective algorithms. Algorithms, often aided by big data, now make decisions in subjective realms where there's no right decision and no anchor with which to judge outcomes, such as what is good, what is relevant, what's important, what's desirable, and what's valuable. These are subjective. There's no objective way to do this. We decide, and then we judge. And so when we're looking at quality control and newcomer assessing algorithms, we're really asking the question, who's allowed to participate in Wikipedia? Who gets labeled bad faith or a vandal? What types of contributions will be labeled damaging? If we're not careful here, we can introduce biases. We can silence entire audiences to Wikipedia. So let's look at this, this quality control prediction algorithm, the one that's predicting whether an edit is good or bad. You know, this is obviously something that could filter the type of content that's in Wikipedia. We also have an algorithm that predicts whether an article is high quality or low quality. We might end up paying attention to the wrong articles because we assessed them wrong. We're even just in the process of implementing algorithms that will predict whether a comment on a talk page is harassment or it's civil. So there's one more comment that I want to highlight here, and this is a comment that WNT made on the signpost when we first started advertising ORS on English Wikipedia. WNT advised us to please exercise extreme caution to avoid encoding racism and other biases into the AI scheme. Essentially, the idea is that our prediction model might not just predict harassment and civil, but we might accidentally, for example, lump harassing messages in with messages, say, from South Africans because they speak a particular way and our model just happened to pick up their way of speaking as harassment. And now we have a feed of people who are getting upset with South Africans who are posting messages on Wikipedia. We need to be very careful to make sure that this is not the case. So I want to tell you two stories about how we ran into these sort of problems with our damage detection model and how we address them. So the first story will be about the Italian word ha and how we started catching, the Italian word ah, and how we started catching those as damaging edits, and how we ended up flagging most edits by anonymous editors as damaging. Okay, starting with the Italian ah, this is literally not a laughing matter, and that'll make sense in a moment. In November of 2015, we got a post on the talk page for the ORS system on Meta from Rotpunkt, who's one of our main collaborators in the Italian Wikipedia, telling us that one of the types of false positives that they're seeing, one of the edits that tends to get flagged for damage, even though it's not damaging, are edits that add the Italian verb have, this word ah. And so he linked us to a list of edits that he's been maintaining with other Italian Wikipedians that list out these types of false positives. And so that's what I have on the bottom of the page here. It's a little screenshot from that showing a bunch of diffs that ORS had mislabeled as vandalism, and all of them added this Italian word for have, which is ah. And so in order to understand what was going on here, I have to tell you about the source of signal that was happening in the machine learning model. So we have two interesting sources of signal here that are based on lists of words, informals added and bad words added. So bad words we define as curse words, racial slurs, and other sort of purposefully offensive terminology that has no place in an article, a talk page, anything like that. But informals are casual speak that would be welcome on a talk page, but probably not in an article, such as hello or ha ha ha. And ha 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 might give you an indication for what was actually going on here. So it turns out that if we look at the regular expression that we use to catch this type of informal and the tests that apply to it, these links, by the way, if you look at my presentation, actually go to the code so that you can look at where this is in the ORS code that's behind this. You can see that this is actually intended to catch the word ha. And we use the English informals in every damage detection model, even outside of English Wikipedia, because there's lots of vandalism that's in English no matter where you go. And so it turns out that ha is laughing in English, but ah is not laughing in Italian. And so, of course, we sat down, we fixed this by removing that regular expression from the model as we built the Italian prediction model, and we're able to show that in most cases we're able to take these edits from false positives and make them true negatives. And Rotpunkt turned around and made sure that it worked and thanked us for our work. So, victory. Okay, so one more that I want to talk to you about is anonymous editors, and this one's actually a lot more difficult for us to deal with. So it turns out that as we were deploying models for various wikis, almost every community came back to us and said, it looks like there's a bias against anons here. There's something that's going wrong with anons, and you should really look into it. They were dominating our false positive reports even where they weren't highlighted as a trend. But maybe anons are really bad, and the machine learning algorithm is just picking up on that and making appropriate predictions. You know, that's a possibility. It does turn out that generally, anonymous users are more than twice as likely to be saving vandalism as registered users. However, 90% of anonymous edits are good, so we're probably targeting them way too much. And so the first thing that we actually set out to do was make it so that we could clearly see this bias in the ORS system from the outside. And so I'm actually showing a URL on the top of the screen right now that you can load up in your browser. So you can actually ask ORS, make a prediction about this particular edit, whether it's damaging or not. But I want you to pretend that the user who saved it was not anonymous, and that's this is anon is false on the end here. And so when we ask ORS to make a prediction about this particular edit, 642.345.235, and we say pretend anonymous is false, then it says, I'm pretty confident that this is not damage. I'm about 65.6% sure that this isn't damage. This would solidly put this edit outside of the review pool. We would say, you don't need to review this. This is probably good. However, if we request the same URL, but we set isAnon to true, then ORS changes its prediction. It's only now 54.1% sure that this is not damaging. And so holding all other characteristics of the edit constant, we're actually changing the prediction based on this anon value, and you can actually ask ORS and see how it changes its prediction by doing these things in the URL. And so just to make this clear, just by being anon, we score this edit 11.5% more likely to be damaging to the article. And this is actually after we solve the major problem. So in order to characterize this problem, we wanted to look at this by, we wanted to compare two different modeling strategies. We were comparing a linear support vector machine model, which is this sort of top link and screenshot here. That was our dominant model before we started addressing this issue. And a gradient boosting model, which we thought might do a better job of learning the nuance around anonymous editors. We also wanted to ask ORS to make believe that all editors were of a certain type. So holding all other characteristics of an edit constant, we set up these user classes. So we wanted to look at anonymous editors, new editors, and I used myself as an example. I'm user epochfail, and so I've been around for 8 years since I registered my account. And you'll notice there's more than just the isAnon feature here, and that's because you have to set a few other features just to make sure that they remain consistent. So for example, an anonymous editor, of course, is anonymous. They have 0 seconds since registration because they didn't register. They have no advanced rights. They're not an admin. They're not a bot. They're not a curator. But you can see that the primary feature that's changing here is the number of seconds since registration and the isAnon flag. And so essentially what this is going to allow us to do is say, ORS, how do you change your predictions when you're looking at everybody as these different users, but looking at their edits otherwise the same? And I should mention, too, that we're going to look at edits that have been labeled very carefully by humans as damaging or not. And so this is actually the form that Wikipedians use to help us get a nice labeled data set of damaging and non-damaging edits. Okay, so here's what the predictions look like over the test set if I don't change any of the user classes. And so that's what I mean by natural. I'm just taking the raw data and I'm throwing it at ORS. And so we can see in this plot, this is essentially the density of prediction weight for damaging and not damaging edits. Damaging is in the blue and not damaging is in the red. And so we can see that in the case of not damaging, ORS is really likely to predict a low probability of damaging. In the case of gradient boost, it's almost 0. In the case of linear SVM, it's between 0 and 0.25, so pretty good. And in the case where the edit actually is damaging, both models are more likely to give it a higher score. And so we can see that the blue distribution is further towards the right, much closer to 1. There's also a little weird spike in the linear SVM model around 0.8. We're going to get back to that in a little bit. That's something that I'm going to want to talk about. But the thing that I want you to take away from this is just looking at these plots, it looks like these classifiers are working pretty well. Okay, so now let's ask the question, what if all of these edits were saved by anonymous editors? What would the scores look like then? Okay, so in this plot, we can see that in the gradient boosting model, when the edit is damaging, or sorry, when the edit is not damaging, the prediction weight is very close to 0. This is pretty much the same as we were seeing before when we look at the natural user classes. But in the linear SVM case, most of the prediction weight is actually above 0.75. So even whether the edit is damaging or not, the linear SVM distribution almost looks exactly the same. Essentially, it's barely able to distinguish damaging from not damaging if the editor is anonymous, whereas the gradient boosting model can do a pretty good job of differentiating damaging from not damaging for anonymous editors. So that's interesting. So it seems like there's definitely a problem with anonymous. What about for newcomers? Turns out basically the exact same story. If you're within 2 hours of registration, the gradient boosting model can do a pretty good differentiating damage from not damage, but the linear SVM model can't do a good job at all of differentiating these things. It basically says if you're anonymous or you're a newcomer, you're probably saving vandalism. That's not quite fair, and that's not what we want to do. Okay, now finally, let's look at if it was me, if I were saving all of these edits, damaging or not. So it turns out that in this case, actually, both models can't distinguish. For the not damaging, get low scores, which are great, but for the actually damaging edits, none of the predictions, or almost 0 of the predictions, actually make it above 0.5, which is the threshold that we set for actually needing review. So really what this means is if we rely on ORS entirely, I get to vandalize Wikipedia and never get caught. So it turns out that we need to be careful in this space. This is something that we learned in this process of getting these false positive reports and trying to understand the characteristics of it. We learned that the gradient boosting model is obviously better and is much better at distinguishing damaging from not damaging edits, especially for new editors and anonymous editors. So we got the gradient boosting models deployed as soon as we could. They've actually been live since December of 2015. But this still needs work. As you saw in that last plot, there's still a substantial bias against anonymous editors and newcomers. It's lessened, but it's not gone. And so we're working on new sources of signal, specifically hashing vectors to context-free grammars. These are strategies that look at the actual change that's made in the edit rather than the characteristics of the user to try and make judgments about what's damaging and what's not. All right, and finally, part 3, I want to make a little bit of a call to action to my fellow AI designers out there, and really to say, how about we ask the humans? So in evaluation of artificial intelligence, we generally use a set of quantitative strategies like accuracy, precision, recall, F-score, receiver, the area under the receiver operating characteristic, or the area under the precision recall curve. These metrics are really good at answering the question, how well does my classifier work in general? And as we remember from those first plots that I showed you, both of these classifiers actually work pretty good in general. But we saw that really weird spike in the linear SVM case of false positives, and I'm pretty sure that those were the edits by anonymous editors. So these general high-level evaluation metrics aren't really good at answering the question, does my classifier behave strangely sometimes? So here's what I propose that we do on top of the quantitative evaluation metrics. We follow a two-step process. First, deploy the model to a live environment and advertise the fact that it is experimental and imperfect. So this is an excerpt of the message that we send to wiki communities when we deploy ORS. ORS is an experimental technology. We encourage you to take advantage of it, but also to be skeptical of the predictions made. It's a tool to support you. It cannot replace you. Please reach out to us with your questions and concerns. Then take feedback, iterate and retrain your models, and redeploy. And I think that this is insightful because despite the black box nature of AI, humans are actually really good at noticing patterns and trends, especially in spaces that are of direct concern to them. And so it turns out that, yes, AIs are black boxes. It's very hard to see how they're actually making the predictions that they're predicting. But so are humans. Humans are actually black boxes too. I don't know what your neurons are doing, and if I did, it probably wouldn't make sense to me. But it turns out that we do this all the time. We make judgments about each other. We try and see the biases in each other so that we know how to relate to each other, so that we can understand each other's judgment. And so I think that human evaluation of AI's biases should be part of the standard practice of AI designers working in social contexts where we have these dangers of accidentally locking people out of contributing to open knowledge. And with that, and with a lot of more hard work, one day maybe we will get to this tranquil lake. Thanks.
So we have one question from ILC. Abby, let me know when I should ask it.
Go ahead, please ask.
Okay. So the question is from Ed Summers. He wanted to know how much edit history had been used to train the classifier.
So most of our edit quality models are, which like we predict whether it will likely to be reverted, whether it was saved in good faith, whether it was damaging to the article or not. Those are trained on about 20,000 observations. And it seems that we get about the same fitness with 10,000, but 20,000 is nice so that we can get a nice solid test set. So yeah, we've sort of settled on 20,000 as sort of minimizing the amount of labeling work that our users have to do and maximizing the number of observations that we can get so that we're generalizable.
Does anyone else have questions they'd like to ask?
Yeah, I actually have a question for Aaron. So when you look at the Anon, so do you think that the problem is more in the feature itself, or in the way the machine learning model picks it up? So I imagine that you must do feature selection or any kind of regularization to avoid overfitting and so on. So that makes me think that perhaps we should also start thinking about looking at the impact of features post-learning, right? Because in that case, that feature would give always the same answer. And that sounds to me like something that is weird with it, right?
Yeah, no, I think that that's right. I think that the linear support vector machine was particularly susceptible to this. So it was both a combination of the algorithm and the sort of like dominant prediction power of this particular feature. I think that the gradient, well, any sort of ensemble model that does sequential estimators has a much better opportunity to learn the error around like a strong predictor. And so that's why we ended up looking in that direction. But I mean, ultimately, I think that the real future here is to figure out how to not include user classes like is and on at all in the model. It would be great if we could judge everybody the same. The balance that we're really trying to strike right now is one between efficiency and being fair to people. And you know, if we were to take is and on out of the model, we would lose a lot of efficiency. Essentially, we would be doubling the workload for people. And it does seem that it's not just pure bias that the predictor brings to the model. And so rather than remove it from the model, which is actually something that I'd like to talk about. If a community was really interested in removing the bias and was willing to remove that from the model, I'd say rock on, let's do it. But I don't think that they are, and so that's why I've been pressing really hard into new sources of signal. I'd really like to be able to say, hey, we found enough signal that we can remove this predictor, and you'll maintain efficiency.
I have a quick question if no one else is waiting.
We have two questions from IRC, but you can ask yours and I'll go after it.
Yeah, I'll wait.
Okay, so one question from Tillman, more of a clarification. So when you indicated the calculation for the time saved, so you probably assume that all patrollers trust ORES entirely, meaning that they no longer check the edits that ORES classified as benign. Is that correct?
Yeah, that is the assumption that we're making.
Okay.
Mm-hmm.
And the other one was about the bias. So Tillman's comment was, wasn't the model built on human judgment in the first place? And if that's the case, how much of this bias against anonymous editors is an artifact of the machine learning method used, and how much is it the judgment of the human scorers?
So the labeling interface that I showed really briefly actually hides the characteristics of the users, and we do that on purpose. That is a feature request that I have regularly fought against implementing, showing which user saved the edit when people are evaluating whether it's damaging or not. You know, but we do show the revision ID. If somebody's clever, they can go back to Wikipedia, go find out which editor saved this edit, and then make their judgments based on that. That would take them a lot of time, and generally people working with this interface are trying to go as fast as possible. And so I think that generally that's not the case. Although, you know, you might be able to tell by characteristics of the edit whether the editor is likely to be anonymous or not. Of course, we can't control for those sort of things. But there's sort of this larger question around bias. You know, we are dealing with human judgments, and humans do bring bias to it, whether it's directly at anons or something like that. I think that what we can strive for, though, is trying to only have a first order of bias, having one human judgment's worth of bias, and try to avoid feedback loops. For example, if we trained on past reverts that were informed by ORs, we would be perpetuating a bias and then relearning that bias, and now we have two layers of bias. And so we can never fully get rid of it, but I think that we can still try to minimize it, and getting away from those kind of feedback loops is one way to do that.
Thank you. No more questions from IRC.
Yeah, I had a related question. I was wondering, so you have this labeling system to come up with a more objective training set and test set, and I was wondering if you're interested in kind of reverse engineering the bias that editors show in the edits that they choose to revert by comparing it against the cleaner set or comparing it against ORES.
I think that's a really interesting idea. So like we have two options for doing that. One is we just have the reverted model, and so we can predict which edits are likely to get reverted but not damaging. And we also have the option of using this damaging model and the good faith model to look back at edits that were reverted and try and predict whether they were not damaging or not for review. And so I think that that's a really interesting idea. So there's this idea of meta moderation. And so like the first moderation would be, should this edit be reverted or not? And then meta moderation would be, was this a good revert or not? And I think that using this type of strategy, we could essentially sort reverts by the probability that they ought to be reviewed. And so yeah, I think that's a really interesting idea.
Well, with that, we're just a little bit over time, so I think we should end here. And thank you for presenting both, and thanks everyone for attending. Bye.
Take care, folks.
You too.